How do you think, Keynes is, capitalizing on this growing trend of India becoming a hub for semiconductors?
I talked about the manufacturing value chain of semiconductors and how it's broken up into front end and back end. And I also talked about Keynes as a leader in India today on the back end of the manufacturing on the EMS side. That's the electronic manufacturing services. Once the chip is on the board, and then they put the chips on the board, and they also do end box builds. So, for example, they're doing the 3000 CDAC Rudra supercomputers for the country. It's very logical once you're in that dominant position after a very successful IPO to look at the adjacencies on the value chain, upstream and downstream. And so you start asking yourselves, what are the necessary inputs that I'm currently importing or buying from outside that I can do it myself? So now we're on an aggressive expansion plan on bare PCB fabrication. So instead of importing them from Taiwan or Korea or from India for that matter, we want to make them ourselves. Totally different than EMS, right? It requires a lot of chemicals and acids and the bare boards, copper plating, etc. So we believe this is a very strategic approach for the future, for the next decades to come, and to build high quality, multi-layer, advanced PC boards with through vias, with advanced technologies for the IoT market and computing market. Number two, as I mentioned, the packaged parts come to us on tapes and reels and on trays. Then we thought to ourselves, in addition to the bare PCB, which we're putting these chips on, what about the actual package that goes on each and every one of those components? And the government scheme has come up with the PLI scheme to promote manufacturing of downstream components. So we put in our applications with the Indian Semiconductor missions. We will get approved shortly. We've also put in our applications at 3 states, and we're awaiting the approvals from the states. Once the states decides, we're going to make a decision, but that doesn't stop us. So what we've done is we've built infrastructure in all the 3 states, and we're waiting for the approval, and then we'll do the OSAT. If we don't do the OSAT, we'll do the EMS, because we're on such an expansive growth rate. We can't make enough of these plants, these factories. So on the OSAT side, uh, we will take the die from the outside of the country, from TSMCs, UMCs, SMICs, the global foundries of the world. Maybe Micron may be interested, but Micron is doing it themselves. We'll see. And we'll take those wafers, we'll dice them up, and we'll put them in packages. And we're going to put our own packaged parts onto our own boards and put those boards through the EMS. So it's a expansion of the value chain now. It's very logical. We're going to be starting with a little bit lower end packages, probably on the high power photonics area for power electronics for EVs, battery management systems, because we're a leader in manufacturing and automotive, by the way. All the top OEMs are our EMS customers. And we believe that we would like to get closer to our customers and understand their challenge to bring their bill of material costs down also. So we're focusing on automotive and power electronics and QFN packages. And we have a roadmap for the next 4 years to expand to ball grid array, which are called BGAs. I don't want to get too technical, but a little bit less form factor without leads. And then the ultimate is getting into what's called chiplets and substrate-based designs. And those are literally cities inside of a chip where you're going vertically. You're stacking memories, you're putting chips on top of chips, and you're flipping chips inside of chips, and you're putting chips on substrates, and you're building little cities inside of the chip, literally. And that's a very interesting market for India, because you can have one chip from one fab, another chip from another fab, another chip from another fab, and put it all in a single package. You can have a 40 nanometer chip for automotive, you can have a 4 nanometer chip for vision, and you can have a gallium nitride chip for high voltage, all on the same chip. And these are getting smaller and smaller, and companies like Viswadeep's are working day and night on reducing the power. Today, your MacBook now is able to run for 20 hours, 23 hours. Your mobile phone now is charging in 5 minutes, and it's able to run for 20 hours. This is just the tip of the iceberg. So Keynes is very clear that the compute, the infrastructure, the manufacturing we can confidently say, will never catch up with the needs and the voracious appetite of AI. The world will always be doing catch up on AI. So the opportunity is space for young engineers. The opportunity is massive for young engineers coming into this industry.